Hello class. This week's lesson is Chapter 9, Lesson 2, Population and Community. Part 1, Population, where we'll find it in our textbook, pages 316, 316 to 319. Okay, let's first recall the levels of complexity when it comes to nature's existence. First of all, we have an individual, which is one creature out of one population. For example, one zebra. And then a group of individuals form a population. A population is the same species living in the same area at the same time. So let's say group of zebras. These populations join together to form a community. The third level of existence complexity. A community is different populations, and populations are different species. So let's say we have group of zebras plus group of deers. They make up a community because they're different populations. And then we have an ecosystem. An ecosystem is not just the groups of zebras, it's not just the different populations in one place, it's the different populations, so it's the community plus abiotic and biotic factors. How? We have the sun, we have the rain, we have the river, we have the trees. All these are part of our ecosystem. Now the most important part, the last part, is a biome. A biome is the geographic land. It's the geographic area that holds this community together. So these are the levels of complexity of existence. But the one we are going to go into in details for this week is a population. So keep the word population in mind because we're going to go into factors. We're going to discuss a population size and density, as well as the limiting factors of population. I know all these terms are a bit new, but we're going to go into details of each and every one. Remember when we talked about an ecosystem and how it could be as small as a puddle, as large as a rainforest, or as humongous as Earth? Let's think of the same concept, but population-wise. The population of fish that might live, the population of fish that we have here, they might live in a lake, some very small area, or it can live in a huge area like the ocean. We also took earlier that there are biotic and abiotic factors that affect the organisms in an ecosystem. Let's focus on a single fish in the lake. Keep your concentration on this single fish. This is an individual because it's one member of a species, and all these are a population. Okay, so what are factors that affect this fish in the lake? Simple, we already know them all, right? The abiotic factors that affect aquatic biomes: sunlight, temperature, salinity, and dissolved oxygen. But 2 or 3 factors that we really can observe are sunlight and temperature, because they depend on the depth and the salinity, which technically characterizes a biome as freshwater biome or marine water biome, where these are the abiotic factors, but they're not the only factors that affect this fish in the lake. We have other factors, like what? These factors affect a population. How? For example, the plants are biotic factor. The plants that this fish eat. Another thing, other fish that eat this plant, that eat this single fish we have, that prey, let's say, on this fish or eat. So These factors, as they change, they're gonna change the population. Because what if the plant that this fish eats changes? What if it's a sick plant, for example? It's gonna affect the fish that's gonna eat it. It might get sick as well, or it might die. Or if this fish disappears, this plant disappears, this kind of plant that this fish eats is dead and it does not exist anymore. This might cause the fish to move to another population, to another area, because it cannot find its resources, it cannot find its food. Same thing goes to all the other fish. The fish that eat this individual fish that we have, what if this fish moved? These fish will not have food because they eat this kind of fish. So all these are changes that occur in a population because of the different biotic and abiotic factors. Okay, now as we're talking about population, we're going to talk about population size. What do you think goes on with the changes of population size? Well, there are a few factors that affect the population size, and we're going to get into every single one. The first two that we have are ones that we all know of. First of all, birth rate and death rate. These two factors affect population size hugely. The other two factors are immigration and emigration. Okay, so what's the difference? It's an EM and an E? Is that what you're telling me? No, let's look at it a bit more clearly. Immigration is when individuals move into a population. Emigration is when individuals move out of population. Okay, so these are the factors that affect population size. We all know when new babies are born or when people die, this affects the size of a population. How many individuals are here? They're affected. Also, if we have lack of resources or extra resources, this causes immigration and emigration. We're gonna go and see the relationship between each and every factor of these. So let's keep our sentence, what if? What if birth rate and immigration are higher than death rate and emigration? What do you think would happen to the population? What would be the result? What is going to change in the number of population we have? Well, because there's a lot of new babies are born and individuals are moving into our population, the population number will increase. Population rate or size will increase. I hope we're clear on this point, because we have new babies and we have new individuals joining our population as they immigrate, so our population size is going to increase. Let's write it clearly. I hope everything is clear. Let's look at it in the opposite direction. What if again? But birth rate and emigration are less than death rate and emigration. So a lot of people are dying and a lot of individuals are also leaving this place. What would happen to the population? So, population size. What do you think? It will decrease because there are a lot of individuals are dying and also individuals are leaving this place. So, this is going to be, these are some factors and relations between the changes in population size. Also, another factor affecting population size, let's think of it as an ecosystem. The ecosystem itself if an ecosystem is changing, well, how can an ecosystem change? Well, okay, let's look at the aquatic biomes we took last week. Ponds. If there is no rain, rain is minimal, ponds will shrink in size, and if they shrink, some fish might die. So this also tells us that the ecosystem itself changes the population size. Okay, now let's look at population density. Pretty simple, pretty easy. Population density. What is population density? Population density is as simple as it gets. It's simply how crowded an area is. How many people are in this spot, in this place. Let's think of it in mathematical forms. Population density is the size of a population compared by what? The amount of space available. Okay, so let's actually put it in a formula to make it simpler. Population density, PD, equals number of individuals over unit area or volume of space. Or volume. Okay, so a very dense population may have one fish. Okay, let's say very dense population may have one fish for every cubic meter, for each 1 meter cube of water, which is why this very dense population affects the organisms, as organisms may not have enough space to live, may not have enough resources, and they're so close and tightly packed that in a way that it might increase the illnesses and disease. Let's take a couple of examples on calculating population density. Let's say there was, let's go with black, a fish tank. Let's say there was a fish tank of volume 300 meter cube. And this fish tank has almost 30 fish. Find the population density. Simple, really, really simple. Let's recall the formula. The population density formula equals number of individuals over area or volume, right? What's the number of individuals here? A fish tank of volume 300. 300 meters cube or area, volume, number of individuals. It's a volume. So, volume equals 300 meter cube. How about the number of individuals? The question told us we have 30 fish, or 20 seashells, or 80 crabs. They give us something countable, something we can count. That's what you think of when thinking of number of individuals. So, number of individuals is 30 fish. Okay, so the formula is number of the individuals, population density equals number of individuals, which is 30 over area or volume, 300, 0 goes, equals 3 over 30. And I'm sure grade 7 are grown up enough to know we can simply divide it by 3, so it's 1 over 10 equals 0.1. So our population density equals 0.1. Bear in mind, population densities don't have a unit, okay? Now, let's take another example. Let's say I have 25 seashells on 5 meter square, 5 meter cube seashore. So they gave us the area of the seashore, they gave us the number of individuals. So what is the population density? Population density, let's recall it, it's number of individuals, which are 25 seashells, over the 5 meters square, sorry, not cube, because this is not volume, this is area. Meters square, seashore, 25 by 5 by 5. So we have 5 as our population density. These are pretty simple, right? Let's go with something a bit more challenging, let's say. But I'm sure 7th graders, you guys are awesome. It's going to be easy. So let's say I have population density of 200 and an area of 30. Find the number of individuals that can live in this area. How can we find the number of individuals? Let's recall the formula. Our formula says population density equals number of individuals over area or volume. Let's plug the things in place. How will it look like? It's going to be like 200 equals number of individuals. Let's put X, because we know in math anything that we don't know, we'll put an X. Above the area, 30. Below it is the area of 30. Okay, simple. We already know that any number has below it 1, right? So let's cross multiply. You know what cross multiplication is, right? So X multiply 1 equals 200 multiply 30. Okay, what happens now? X multiply 1 is what? Anything by 1, X. So 200 by 30, 6,000. So the number of individuals that can live in an area of 30 meter cubes with a population density of 200 are 6,000 individuals. Okay? Okay, let's look at the last example of population density calculations to move on into limiting factors. Okay, let's say I have a desert with 30 camels and population density of 200. Why am I choosing the same numbers? I have no idea. Okay. Anyways, so the formula is population density equals number of individuals over area. So the population density is 200. Our number of individuals are 30 camels over X. The same thing exactly. Cross multiply again. So we have 200 multiply X is 200X equals 30 multiply 1 equals 30. So X equals 30 over 200. So it's 3 over 20 number. It's the area that contains 30 camels and has a population density of 200. Okay, now we're going to get into limiting factors. Let's simply start with the definition to actually make it as clear as possible. Limiting factors, what are they? Factors from their name that limit, right? It's pretty clear. But they limit what? The growth of a population. So limiting factors are factors that limit the growth of a population. They prevent the population from growing larger and larger. Things like what? Let's look at some factors that limit the growth of a population. First of all, availability of resources. Resources like what? What do you think are resources that animals need to survive? Of course, water, space, food, and shelter. I think water and food are very clear. Shelter is the home. All living organisms need a home. And space, like when we were talking about population density, and we were saying that if the place is too tight, they'll not have enough resources, they might not grow to the right size, and they might even have illnesses and disease because they're so tightly closed. Other factors that affect the limiting factors in an ecosystem, in addition to the availability of resources, we have predation. What is predation? Let's think of an example. Predation is a relationship between a prey and a predator. What sort of prey and predator? For example, a deer and a lion. The lion is the predator that eats the deer. So this is a kind of relation that limits the existence of the growth of deers. Limits growth of deers. What limits the growth of deers? This predation of the lions that constantly feed on deers. This way, the population of deers will not grow, especially that lions are not the only organisms that take deers for food. So this is the second factor that limits the growth of a population. The third factor that limits it is competition. Competition. Which animals do you think have competition in between? Let's think of lions and cheetahs. Lions and cheetahs technically prey the same organisms or very, very similar prey. For example, both eat deers. So there's always going to be a constant competition between lions and cheetahs. Who's going to get to the prey first? Who's going to go faster? Who's going to eat more? What if deers get extinct? Who's going to have the last deer to eat? So there's constantly a competition between lions and cheetahs. So this relationship also limits the existence of, also limits the growth of a population. Not to forget that if deer is extinct, they will not have food to eat, which is very, very important. And the last factor that affects the growth of a population, disease, sickness, that could kill organisms, either by killing the prey on its own, because the prey is sick, or if a predator eats a sick prey. This way, sick prey. Okay, so this way, both are going to be dead or sick, depending on the severity of the case. Let's think of it this way. Let's think of a fishbowl. Simply, a fishbowl. Okay, the limiting factors could be the size of the bowl. Let's say there are fish here. My drawing is amazing. They look like eyes. Okay. The size of the bowl is the first factor that affects the population, affects the growth. Also, the amount and temperature of what? Water. The amount of temperature of water also affects, because we already know temperature is very important. They need to have constant temperatures to be able to maintain good, stable conditions. Also, any of these either size, amount, or temperature of water, they can all limit the number of fish that can survive in the bowl. So this is when looking at the big picture. We're gonna go next into other kinds. Okay, now we're gonna go to biotic potential, carrying capacity, overpopulation, and extinction. These four subtopics go under limiting factor, as they're all connected in some way. Let's go first for biotic potential. What is biotic potential? It's the ideal world, technically, which really rarely exists. How can we define biotic potential? It's the potential growth of a population if it could exist in perfect conditions. Of a population if it could grow in perfect conditions. Let's elaborate a little bit. What do you mean perfect conditions? How can it grow? Okay, let's give an example. Let's think of a population of unlimited rabbits. There's unlimited food supply, unlimited land to live on, and no predators. So they have food, they have shelter, they have safety because there's no predation, no predators, no other organisms will eat the rabbits. This population will continue to grow until it reaches this biotic potential. When it reaches this biotic potential, it means that we have perfect conditions, no predation, all the organisms are safe, surviving, eating, reproducing, growing and developing, everything is normal. And biotic potential leads to highest birth rate and minimal death rate. So, high birth rate and low death rate. So this is biotic potential. But we already said biotic potential is an ideal world. And our world is not really ideal. There are lots of ups and downs, a lot of issues, which is where carrying capacity comes along. Carrying capacity is when biotic potential cannot be reached because biotic potential is too ideal. So populations that do not reach biotic potential reach carrying capacity. What is carrying capacity? Carrying capacity is technically the largest number of individuals that of one species that a population, that an ecosystem can support over time. So technically, carrying capacity is the largest number of populations that an ecosystem can support over time. Can support how? With enough food, shelter, minimal predation, enough water. So carrying capacity is of course controlled by the limiting factors. And we do remember the limiting factors from the beginning of the video, right? Okay. The next part that we're going to discuss is overpopulation. What is overpopulation? Overpopulation is pretty simple. It's from the name, overpopulation, which technically means population is too high. Too high for what? For an area to support. I hope it's clear. Overpopulation is when the population is too high. There are a lot of living organisms living in an area that cannot support it. So there are not enough resources, not enough life survival needs. Okay, so overpopulation leads to what? First of all, leads crowding. The place is too crowded. The population density is very high. Lack of resources, because they're all competing to get the resources. They all want survival. And because of the crowding and the lack of resources, we eventually have an unhealthy environment. All these are affected by overpopulation. Just like we have overpopulation, we also have extinction. What is extinction? Extinction. It's just like population, overpopulation, there's extinction as well. How? It's when all populations die or move out, emigrate out of a specific area. Let's think of the effects of extinction on population size and density. What does extinction lead to? Okay, let's think of rabbits. What if rabbits extinct? Animals that feed on rabbits, like foxes, wolves, or coyotes, will decrease. So, the predator of this specific species decreases in number. So this is the first thing. It decreases why? Either because of death or they emigrate. They move out of this area. This way, we are technically done. We talked about population, population size, population density, and the limiting factors that affect a population in many different ways. I hope everything is clear.